Okay, we are into compound angles and double angles, all the identities popping up everywhere now. Okay, it's number N and O and N. Question says, simplify without a calculator. Immediately your mind thinks special angles. Nothing special about 40 and 25. What are you supposed to be noticing the more that you practice these sums? Where's the double angle? I don't see it. Not yet. Until you write. Because it's always a 2. So now what do I do with that 4? You just write it in another way. So you've still got? Okay, and how does it help me? Because that is a double angle identity, which is what? Sin. Double that angle, which is sin. 50. The rest of the sum? State 2 and state cos 40. Cos 40. One of them, it doesn't matter which one. Either you're going to make sin 50 cos 40 or cos 40 sin 50, but you have to show me. You can't just say sin 50 cos 40 cancel out. You have to show me that you know that they get to be the same, and that answer is equal to 2. Right, then wake up. Then with this one, this was an interesting, weird, strange, unique type of one. Because I'm also saying no calculator. Now you have heard something about 15 and 75 and 105, where I said to you, if they say no calculator, it should be something that you can do with 60, 45, 30. And 15 you can say is 45 minus 30, right? And then that one as well, you're going to elaborate. And then you could do that sum on that way. But I want to teach you something else. If you time in the half here, what is this going to become? Half, and that's going to be root 3 over 2 of what? Still cos 15, still sin 15. So what actually happened there? I timed the half in. But a half, root 3 over 2. Oh, special angles. Good for noticing that. Because you tend to say sin 30, yes, special angle. Cos 45, yes, special angle. But can you recognize root 3 over 2 as a special angle? Yes. And the half as well, because half is the one that you should know by heart, which is sin 30, right? And then cos 15 still stays the same. Where am I aiming? Sin, cos, sin, something like that. But then also just behave yourself, because root 3 over 2 can just as well be sin 60 or
cos 30.
Cos 30. What would you like it to be for the little pattern to work out? Is it still sin 60? Yes. But I want to see the pattern. Sin cos sin. More important, well, of the same importance, 30, 15, 30, 15. So that you see, well, it's sin cos sin, it has to be a sin compound angle of 30 and 15 that must be added. Because if it was the cos one, you change the sign. Making it sin 45, and the answer is root 2 over 2. Are you happy on that? Yes. Would it have worked out if you had gone compound angles there, worked it out? Compound angles there, worked it out, time with root 3, time with a half, add them all up together, put the special angles in there, would you have gotten here?
Alternative.
But it would have been lots and lots bigger. Alternative, quite right. Okay, now the next one also, simplify without a calculator. Well, no calculator can be used anyway because you've got all those x's there. So what are you going to do with, oh boy. Now tell me what some kids are going to write for me. 3. Please slap yourself if you thought that, because it's not true. It means that you're taking cos and you're putting them in a bracket and adding them together, which is untrue. That's actually what you're doing, saying 7x plus 3x. And that's not true because this is a compound angle formula which is going to be cos cos, sin sin, which is not that. Are you with me?
Yes, ma'am.
I want to show it to you because I tend to think it's going to be. It's a logical untruth. Okay, but I need to get somewhere with either my compound or double angles. And how would I get there? By simplifying something. So maybe double, oh, I can't even do doubles because it's 7. If it was 8x, I could have maybe said 4x and 4x in a compound angle. So this is not. I'm trying to do the sum by manipulating it so that I can get something that's the same. Now thinking about that, what can I get as a compound angle for 7x?
5x plus 2.
Let's make it 1x plus 6x. Is that true?
Yes, ma'am.
Yeah. And 2x plus 5x. And 4x plus 3x. And you with me? But I need it to be the same so that if in some manner I can get something that cancels out or simplifies by being added together. So I'm asking, what plus what or minus what is going to give me 7x? And the same two things gives me 3x.
And let's think first.
5x and 2x.
5x and 2x? How are you going to do 5x and 2x?
Oh, yeah. 5x plus 2x. 5x minus 2x.
5x minus 2x.
Make sense?
Mm-hmm.
Can that happen?
Yes.
Could you have had 4x plus 3x? Oopsie, but it's not going to give me 3. Are you with me? You had to manipulate to get it the same because what's happening here now, and we tend to not want to make it bigger, make the circle bigger. We want to make it smaller, but I'm unfortunately having to do this. I'm going to have to elaborate and make this cos, sin of 5x, 2x, 5x, 2x.
Plus. Minus.
Okay, just getting this pattern. And then plus, fortunately for us, I don't have to use brackets. It's also going to be cos, sin of 5x, 2x, 5x, 2x. Don't get bored with the whole method, it's giving you marks. And the sign should be a
Plus.
plus. That plus was no problem. Happiness on that?
Yes, ma'am.
Okay, so now, did that help me at all?
8.
Which ones? The cos 5x and 2x are like? And this, yeah, they are also like. But this is nothing. Because it's like a minus AB and plus AB, which is nothing. So that actually cancels out. But this is not nothing. It's one of them and one of them giving me. Now, when I originally did the sum with the other class, I thought maybe we can still go on because here's a double angle, but the sum, I think, is not given nicely in the textbook because they didn't say, they just said simplify. So now how far do I go to simplify? Now I do agree that this is the simplest way because if you take this now to double angles, you're going to have what time, which is even more elaborate. Maybe I would have rather said simplify to a single term because now it's one term. Okay, guys, you know that we are busy on compound angles and double angles, and that's going to be swarming everywhere. Even in the identities, the ones I like to call the left-hand side, right-hand side. Because if I say identities, you think sin squared plus cos squared, tan is sin over cos, it's true. But if I say left-hand side, right-hand side, you think those big sums where you've got to manipulate with all the identities to get them to be equal to each other. And now, including last year's ones with all the identities that you knew, you also now know compound and double angles. Now, I'm going to help you because we don't have a lot of time to see what I want you to see. And now, if ma'am only did that for you in the exams, can you see what I want you to see there in green? That's a double angle. Even if the 2 is not right in front of it, it's all multiplied, so I can put the 2 there if I want to. And then that would be what? Sin? 2x. That is a double angle. How about the cos 4x? And the minus, and the rest. Stayed the same. Can you see that the color helps you a little bit? If you highlight it, maybe. That the 2 sin x cos x is a sin double angle. Double what? Double x. Have a look at it now. The bottom is tan. Who has an inclination on what to do with tan?
It's cos.
Double cos. At the moment, I'm not seeing where I'm going with it, so let's just leave it on ice. But the top, it's compound. See it? Sin, cos, sin. 4x, 2x, 4x, 2x. This time we're going smaller. So definitely this is a sin. Compound. 4x and 2x. And the minus in between. Still the tan 2x. I'm thinking tan is going to become? So then sin what? 2x over cos 4x. Somewhere. Even if you did it right at the top, that would be with them all. And then how does that help me? So the top became sin 2x. The bottom is now multiplied by cos 2x over sin 2x, which will fall away and I'm left only with cos 2x. And there was our aiming. The sum originally said, I didn't write it down, prove that that is equal to that, and you split it up into left hand side, right hand side. Isn't the right hand side though? What is this?
It's a
Double angle formula for
cos.
cos. This is cos 2x. And then I can say left hand side is equal to the
Right hand
right
side.
hand side. Now normally we say to you, please don't do a whole sum of 5 steps on the left hand side and on the right hand side, because normally if you make a mistake, this side you do it in one direction and the other one you do it in another direction, and you get to the same mistake and you still think your sum is right. But you are allowed to work on both sides. As long as you don't make mistakes, nobody can stop you. Say for instance you stopped here with the tan 2x at the bottom, and on the right hand side you manipulated and got to exactly that same step, and you decided to stop there. Left hand side is exactly the same as the right hand side, although there's a lot to still be done, but it's equal. You're done. Are you with me? There's a lot of ways to do it. Alternative. Are you with me?
Yes, ma'am.
So I'm going to give you more sums like this, and I'm going to put it on the group for you, okay?
Yes, ma'am.
Huh?